Okay, hi everyone, welcome back to this live stream for Windows Server 2003. Just want to share my screen, share. Okay, security filters. A security filter ties security protocols to a particular network address. The filter contains the source, the destination address involved using a net mask for either specific hosts or networks, the protocol used, and the source and destination ports allowed for TCP and UDP traffic. For example, you can define a filter, as you'll see later in this chapter, that specifies exactly what kind of IPsec negotiations you're willing to allow when a machine in your domain contacts a machine in the Microsoft.com domain. Recall that IPsec connections have two sides, inbound and outbound. That means that for each connection, you need to have two filters, one inbound and one outbound. The inbound filter is applied when a remote machine requests security on a connection, and the outbound filter is applied before sending traffic to a remote machine. Let's say that you want to create a rule to allow any machine in the chalice.net domain to use IPsec when talking to any computer in the Microsoft.com domain. For this to work, you need the following four filters. A filter for chalice.net domain for outbound packets with a source of f.chalice.net and a destination of Microsoft.com. You can use DNS names and wildcards in filters. So I think that was a star there. A filter for the chalice.net domain for inbound packets, this time with a source of star.microsoft.com and a destination of star.chalice.net, an inbound filter in the Microsoft.com domain that specifies a source of star.chalice.net and a destination of star.microsoft.com, and an outbound filter in the Microsoft.com domain that specifies a source of star.com Microsoft and a destination of star.chalice.net. If any of these filters are missing or misconfigured, the IPsec negotiation process will fail and IPsec won't be used. If they're all there, when you try to establish an FTP connection from hop.chalice.net to exchange.microsoft.com, the outbound filter on your domain will fire and it will trigger IPsec to request a security negotiation with Microsoft's machine. If everything goes well and the filters are okay, you will end up with two IPsec SAs on your machine and the connection will be secured. You normally group filters into filter lists for ease of management because you can store any number of individual files into a filter list. You can easily build rules that enforce complicated behavior and then reduce those rules throughout your network as necessary. Security methods. Each IPsec connection uses a security method. A security method is a connection that uses a pre-specified encryption algorithm with a negotiated key length and key lifetime. You can use one of the two predefined security methods, high or medium, as you will see later in this chapter, or you can create your own by specifying which security protocols, AH or ESP encryption algorithms, and key lifetimes you want to use for a particular connection. When your computer is negotiating with a remote IPsec peer, the ISAKMP service works its way down the list of methods you've specified, trying to use the most secure method first. As soon as your ISAKMP and the one on the other end agree on the method, it then establishes communication using that method. Security filter actions. Filters specify a source and destination, but they also have to specify what action should take place when the criteria specified in the filter matches using the IP security policy management snap-in. As you will see later in this chapter, you can use the following 5 separate security filter actions in each filter, though you can't combine them in the same filter. The permit action tells the IPsec filter to take no action. It neither accepts nor rejects the connection based on security rules, meaning that it adds 0 security. This action is also called the pass-through action because it allows traffic to pass through without modification. In general, you'll use it for modifications like Windows Internet Name Service, WINS servers, where there's no security sensitive data involved. The block action caused the filter to reject communications from the remote system. This prevents the remote system from making any type of connection with or without IPsec. The 2 actions accept unsecured communication but always respond using IPsec and allow unsecured communication with non-IPsec aware computers. Allow you to interoperate with computers that aren't configured with IPsec. The accept unsecure communication but always respond using IPsec policy says that it's okay to accept unsecured connections, but that your machines will always ask for an IPsec connection before accepting the unsecured request. This action allows you to handle both unsecured and secure traffic with a preference for IPsec when it's available. The allow unsecured communication with non-IPsec aware computers action allows your machines to accept insecure connections without attempting to use IPsec. As such, we recommend that you not use it, but instead use the accept unsecured communication, but always respond using IPsec action. Enabling session perfect forward security PFS ensures that master key signing material cannot be used to derive more than one session key. The use these security settings action lets you specify which security methods you want used on connections that trigger this filter. This option allows you to specify custom settings for either individual computers or remote networks. The upcoming section, Managing Rules, with the Rules tab, discusses an additional filter action as well as a little more about when to use and not to use each of these actions. Security policies. A security policy is a set of rules and filters that provide some level of security. Microsoft includes a number of pre-built policies and you can create your own. In fact, you'll have to create your own policies for things like dynamic host configuration protocol, DHCP, and remote access servers. You assign policies to computers in a number of ways. The easiest way is to store the policy in Active Directory and let the IPsec policy agent apply it to the applicable machines. Once an IPsec policy is assigned to a machine through Active Directory, it remains assigned even after the machine leaves the site, domain, or organizational unit OU in which it was given the original policy. Until another policy is approved, you can also assign policies directly to individual machines. In either case, you can manually unassign policies when you no longer want a policy in place on a specific machine. There are 3 policies you need to be familiar with in the IP security policy management snap-in. The client respond only policies that Windows 2000 XP or Server 2003 IPsec client will negotiate IPsec security with any peer that supports it, but it won't attempt to initiate security. Let's say you applied this policy to a Server 2003 computer. When it initiates outbound network connections, it won't attempt to use IPsec. When someone opens a connection to it, though, it will accept IPsec if the remote end asks for it. The Secure Server Required Security policy specifies that all IP communication to or from the policy target must use IPsec. In this case, all DNS wins and web requests and everything else that uses an IP connection either has to be secured with IPsec or will be blocked. This may not be what you want unless you plan to implement IPsec on your entire network. The server request security policy is a mix of two other policies. In this case, the machine will always attempt to use IPsec by requesting it when it connects to a remote machine and by allowing it when an incoming connection requests it. This policy provides the best general balance between security and interoperability. IPsec authentication. IPsec supports 3 separate authentication methods. Which ones you'll use will depend on what kind of network you have, for example, with or without Active Directory, and to whom you're talking, because the first thing an IPsec client and server want to do is authenticate each other. They need some way to agree on a set of credentials to use. The Windows Server 2003 version of IPsec supports 3 different authentication methods. They're used only during the initial authentication phase and building the SAs not to generate encryption keys. Kerberos. Kerberos is the default authentication protocol for any Windows 2003 XP computer. If Kerberos fails, the computer will automatically switch to NTLM authentication. Kerberos is a widely supported open standard that offers good security and a great deal of flexibility. Because it's natively supported in Windows Server 2003, it's the default authentication method. Many third-party IPsec products include Kerberos support, not that only Windows 2000 and Server 2003 domain controllers running in Windows Server 2003 or Windows 2000 native domain functional level support Kerberos authentication. Windows 2000 and Server 2003 member servers and NT4 servers do not. Certificates. Certificates are public key certificates used for authentication. When you use certificate-based authentication, each end of the authentication can use the other's public certificate to verify a digitally signed message. This provides great security with some added overhead and infrastructure requirements. As you add machines to a domain in Windows Server 2003, they're automatically issued machine certificates, which only apply to specific computers rather than users that can be used for authentication. If you want to allow users and computers from other domains or organizations to connect to your IPsec machines, you'll need to explore certificate solutions that allow cross-organization certification. Pre-shared keys. Pre-shared keys are reusable passwords. The pre-shared key itself is a word, code, or phrase that both computers know. The two machines use this password to establish a trust, but they don't send the plain text phrase over the network. However, the unencrypted key is stored in Active Directory, so Microsoft recommends against using it in production because anyone who can see the key can impersonate you or the remote computer. However, most of the time you use this mode only when you need to talk to a third-party IPsec product that doesn't yet support certificate or Kerberos authentication. So installing IPsec. The components necessary for a Windows Server 2003 machine to act as an IPsec client are already installed by default when you install Windows Server 2003. However, also by default, there's no policy that requires the use of IPsec. So the default behavior for Windows Server 2003 machines is not to use it. The good news is that you don't really have to install IPsec. You just have to install the tool you use to manage it and then start assigning policies and filters to get the desired effect. In the following sections, you will learn how to enable IPsec IP security policies on a Windows Server 2003 computer. So I'm going to leave it here today for this live stream. If you liked listening, please consider like, sharing, and subscribing. Thank you.